Assalamualaikum warahmatullahi wabarakatuh. My name is Hadiawati. I'm with my team Ahmad, Suriadi, Titin, Sugianti, and Fitria Zulhaedar. We'd like to present our result of experiment. The title of our paper is Application of Silicon Foliar Spray to Increase Growth and Yield of Shallot under Sprinkler and Furrow Irrigation System. This paper present at the third International Conference on Bioscience and Biotechnology. The topic is in Bioscience and Biotechnology Research for Environmental Sustainability that will be held on 12 to 14 of October 2020. We are going to the introduction. Dryland of semi-arid climate in Nusa Tenggara Barat province is suitable area for shallot cultivation. The total area for shallot production was about 19,000 hectares with total production about 211,000 tons based on the data of the Statistical Bureau on 2016. There are 4 districts in NTB. The top 4 was Bima at 13,000 hectares for shallot production, and Sumbawa was about 3.3 thousand hectares, followed by East Lombok at 1.3 thousand hectares, and the least is Dompu at 600 hectares. The current issue on sustainable and climate-smart agriculture for dryland area is the use of efficient irrigation system. Our previous study determined the water use of sprinkle irrigation is 84% more efficient when compared to furrow irrigation for shallot production in existing farmer practice of West Lombok district. Silicon foliar fertilizer application is widely reported has beneficial effect on limiting the adverse effect of some abiotic stresses, including reduction of drought stress due to limited water availability. The foliar application of silicon could improving plant drought tolerance and nutrient use efficiency, also strengthen the stem under low light stress, and foliar spray is not only practical but also effective to increase yield. Actually, amount of silica is large in the soil. Most of it is in a form that is not available to plants. Silica is tightly bound with other elements to form silica or silicic acid or maybe silicate. And soil contain 50 to 400 grams of silica per kg depending on the soil types. Although a silicon foliar application has been reported widely, the comparative studies on investigating the rate of foliar application under different irrigation systems for shallot have not been reported for specific dryland of eastern Indonesia. So the objective of this research was to determine the effect of some concentration of silicon foliar spray application on growth and yield of shallot grown under 2 irrigation systems at East Lombok district. The material and method. Site of experiment was at Labuan Lombok village. The average annual rainfall was about 976 mm per year with average 87 rainy days. The soil was sandy loamy in texture with pH around 6.4 and the mean annual temperature is about 35 degrees Celsius. The period of experiment was on May to September on 2018. The design of on-farm experiment was on randomized block with split plot design in 3 replication. The main plot was the irrigation system that under sprinkler and furrow irrigation, and the subplot was for silicon foliar application rate at 4 level, start from 0 milliliter for the control, followed by 15, 13, and 45 milliliter per liter. The material we used the Trisula cultivar that potential in yield about 6.6 to 23 ton per hectare. The silicon foliar fertilizer produced by ICBB pasca panen. The brand name is Biosinta. We also use the cattle manure that enriched with Trichoderma sp to produce the trichocompost. And the fourth, we use the chemical fertilizer such as NPK, Ponska, SP36, and urea. The method: Shallot cultivation system refer to the technical guidance on shallot integrated plant management, including the land preparation, the clearing, optimum tillage, making beds, and also drainage. We also apply the basal fertilizer application, which is manure with additional NPK and SP36. For the second and third fertilizer, we use urea that applied at age 15 and 45 days after planting. The silicon foliar were sprayed at 20 days after planting in a week interval for 4 times. Data collection. For yield, it was measured from the plot yield at 1 meter square during harvest, while the growth data for plant height and leaf number collect at 20 days, 40 days, and 60 days after planting for 15 plants. Data was analyzed using STAR, a statistical tool for agricultural research, and the statistically significant difference between means were tested using Duncan. Here's some photos of the activities. First, the seed, bulb seed that was cut at the tip, and also the planting process and the irrigation process, which was under sprinkler and then under furrow irrigation. The second one, the pictures about the foliar application, and then the concentration was measured carefully. Next, the activity on data collection for plant height and leaf number, and third and the last picture for harvest time, where the yield, weight in every plot in each treatment. The result we can show here on the graph that there was no interaction effect of the irrigation system and concentration of silicon foliar application. Yield of shallot in sprinkle irrigation was significantly higher than furrow irrigation for weight of fresh biomass, weight of sun-dried for 7 days, and weight of bulb seed after 3 months storage. There's also, we can see the silicon spray concentration at 15 milliliter per liter was yield higher under both sprinkle and furrow irrigation. The weight loss also significant for the interaction effect of irrigation system and concentration of silicon foliar spray, mainly on weight loss at both after sun-dried and also 3 months after storage. Despite the produce higher yield at 15 milliliter per liter silicon spray. In this concentration, weight loss after sun-dried was the least under sprinkle irrigation, that 26.40%, and under furrow irrigation it was 30.04%, while the highest weight loss was in control treatment for both the sprinkle and furrow. In this table, we can see some growth parameters including plant height and leaf number at age 20, 40, and 60 days after planting. We can see here the significant interaction effect was found on plant height of Shallot at 20 and 40 days after planting. Irrigation treatment will significantly affect the plant height and leaf number only at 60 days after planting or at the late growth stage. In contrast, concentration of silicone spray was significantly affecting the plant height and leaf number at 20 days after planting or at early growth stage, and also the fresh weight of the plant. When we go deeper to the interaction between water treatment and foliar spray on the plant height, we can see here the silicone spray concentration at 15 millimeter per liter under sprinkler irrigation shows the highest plant height in the both 20 and 40 days, while under furrow irrigation, plant height was higher at application of silicone spray under between 30 and 45 milliliter per liter. So, in conclusion, the result shows that interaction effect was significant on plant height at 20 and 40 days after planting, also weight loss after sun-dried and weight loss after 90 days of storage. Shallot fresh yield was significantly higher under sprinkle irrigation at 3.72 kg per meter square when compared to the furrow irrigation at 2.7 kg per meter square. Furthermore, sun-dried shallot yield was significantly higher than control at about 14.76% to 28.40%. In general, plant height, leaf number, bulb number, and fresh biomass of shallot was increased following the increase on silicon fertilizer concentration. So, optimal dosage of silicon foliar spray for both sprinkler and furrow irrigation at this experiment site was 15 milliliter per liter. I also like to address my acknowledgement to this research is work that support by Sustainable Management of Agricultural Research and Technology Dissemination or SMART-D program for Indonesian Agency for Agricultural Research and Development, the Ministry of Agriculture under KP4S program, which is gratefully acknowledged. Thanks also devote work of all members of Land and Water Resource Unit of Ayat West Nusa Tenggara Province. Thank you.